Hey guys, okay, I said I would post the notes, but rather than do that, I decided that I'm going to make a video of this for you. I think it'll be more helpful. Okay, so what we covered today in class was the distance between a line and a point that's not on the line. So you can think of, some line and some point that's not on the line. And remember that during class I said the shortest distance between the point not on the line and the line is the perpendicular distance. And so I showed you in class a bunch of steps that we used essentially to find this point here at the foot of the perpendicular, and then we would take this point and that point and plug it into the distance formula. So I'm going to go back over the first example we did in class. The example was that the line L contains points -5, 3 and 4, -6, and we want to find the distance between the line L and a point 2, 4. Okay, so if I plot this thing on the coordinate plane, now I can plot these 2 points and connect them to form line L. So if I go over -5 and up 3, then I have the point 5, 3. And if I go over 4 in the x direction and then down 6, I have the other point, 4, -6. And I can connect these 2 points like so. Now the point that's not on the line is at 2, 4. So right about here is my point P. And remember that the shortest distance is going to be this perpendicular distance. So what this is a line. So if I can extend this out there, this is just some point on a line perpendicular to this given line L. Okay? So the first step that I need to do is I need to write the equation of the line in y equals mx plus b, or we call that slope-intercept form. Okay, so the first thing I have to do, given those 2 points, is find the slope. So the slope is equal to y2 minus y1 all over x2 minus x1. And that's going to give me -9. And then 4 minus a minus 5 makes that 4 plus 5. So that's a +9. So the slope of this line L is -1. Now I have to write the equation of this line, so I'm going to use this slope and either one of those points to write my equation. So I'm going to use m equals -1, and I'll use the point -5, 3. And we're going to put that into the point slope equation of a line, right? So y minus 3 is equal to -1 times x minus a -5. And if I clean this up, I'm going to have y minus 3 is equal to -1 times x plus 5. Now I'll distribute. Y minus 3 is -x minus 5. Don't forget to distribute to both terms. And now I'm going to add 3 to both sides. So I'm going to have y is equal to -x. A -5 and a +3 is a -2. So the equation of my line L is -1x, and you can put the 1 there if you want. -1x minus 2. Okay, so remember that this pink line here is going to be perpendicular, and that's why I need the slope of the perpendicular line. So you're going to use the slope of the line L, which is -1, to find the perpendicular slope. Well, the perpendicular slope, you flip it and change the sign, so it's just +1. Okay, and I'm going to use this in conjunction with my point P, which is 2, 4, because this point P lies on this perpendicular line. So now I can find the equation of the perpendicular line. So I'm going to have y minus 4 is equal to 1 times x minus 2. So y minus 4 is equal, if I distribute, I get 1x minus 2. And if I add 4 to both sides, I get y is equal to 1x plus 2. So I'm just going to put a little perpendicular symbol here, that way I know the difference. This is my perpendicular line, and this one up here is the line that was given to me, even though, you know, it was given to me with 2 points as it passes through 2 points. So I had to do some work to find the actual equation, but this is the equation of the line, and the pink one is the equation of the perpendicular line. Now the next step is I'm going to set those two equations equal to each other. I'm going to have negative 1x minus 2 is equal to 1x plus 2. And this is going to give me the x coordinate of the point at the foot of the perpendicular. Okay, so I'm going to add 1x to both sides. So I'm going to have negative 2 is equal to 2x plus 2. And then I can subtract 2 from both sides. So I have negative 4 is equal to 2x. And then if I divide by 2, I get that x is negative 2. So I found the x coordinate, so I'm going to move this back up for a second. This is the point at the foot of the perpendicular, and I just found the x coordinate, which is negative 2. And now I have to find the y coordinate. So to find the y coordinate is easy. I can plug this value of x into either one of those equations to find y. I'm going to plug it into this one. So y is equal to 1 times negative 2 plus 2, which is negative 2 plus 2, or 0. So x is negative 2 and y is 0. And that's, now, you know, my picture doesn't look, so this is a 0 there. Okay, so my picture's off because I hand sketched it, but the point is that now I found this point, and I have this point P, which was given to me as 2, 4. If I have these 2 points, now I can plug them into the distance formula to find the distance. Okay, and that will give you the distance between the point and the line. So let's do that. I have the point 2, 4, and the point that we just found, negative 2, 0. And now we're going to find the distance. And remember that the distance formula is just the difference in the x's times the difference in the y's squared, take the square root, and you get it. Okay, so this is the formula. I just have to plug in my x's here and my y's here. So I'm going to do negative 2, so negative 2 minus 2, and 0 minus 4. And if I straighten that out a little bit, I'm going to have negative 2 plus a negative 2 is a negative 4 squared, plus 0 minus 4 is negative 4 squared. And that's going to give me, for negative 4 squared is positive 16. Anytime you square a negative, you get a positive. Plus negative 4 squared is 16. 16 plus 16 is the square root of 32. And we can simplify that, but for right now, I just want you to know how to do the steps to get the right answer. We can worry about simplifying later. So the distance between this point, P, and this line is the square root of 32. And that's it. This one is more work because you actually have to find the equation, the slope and the equation of the line that passes through the 2 points. Okay, and by the way, this example over here, you can find this. This is exactly on page 215 of your book, so you can go back and see it, you know, in non-motion form, I guess. All right, let's look at another one. Sometimes they give you the equation of the line, so we did one of those in class, right? So for instance, maybe I think we did number 15. So we have a line that has the equation y is equal to 3x plus 1. Okay, and I want you to find the distance between this line, between the line L and the point, let me make one up here, I'm making this up as we go. So I'm going to graph this line, has a y-intercept of 1, so I plot that, and then I go up 1, 2, 3, and over 1 to the right. So my line L looks like this. Right? So how about we use the point 1, 0. So here's the point P at 1, 0. And what I'm trying to do is I'm trying to find the perpendicular distance between this point and that line. Okay? So the problem again is that I don't know what this point here at the foot of the perpendicular is, so we're going to find that. The nice thing about this is I already have the equation of this line. So really what I need to do is I need to find the slope of the perpendicular. Well, that's negative 1/3. The slope here is 3, so we flip it and we change the sign, and that gives us the slope. And let me extend this line out here, this purple line. I don't know if you can see it's purple, but this whole thing is a line, and I'm just trying to find this little distance right here between the point and the foot of the perpendicular. So I have the slope of the perpendicular line. I have a point 1, 0 on the perpendicular line. Now I can find the equation of the perpendicular line. Y minus 0 is equal to negative 1/3 times x minus 1. Y minus 0 is just y, and I'm going to put a little perpendicular there so we know that that's the perpendicular line. If I distribute, I'm going to have negative 1/3 x plus 1/3. Okay? So now the next step is since I have the equation of the line and the equation of the perpendicular line, now I can set them equal to each other and solve for x. And that's going to give me the x coordinate of the point on the line at the foot of the perpendicular. So 3x plus 1 is equal to negative 1/3 x plus 1/3. Now I'm going to go ahead and I'm going to get rid of fractions. So what that means is I've got a common denominator here of 3. Everything else, you can think of these all as over 1 if you want to. But since 3 is the only denominator, then I'm going to multiply every term, both sides, by 3. And what happens is there's nothing to cancel out from the denominator in this term to this, so I just do 3 times x gives me 9x. Again here, there's nothing to cancel between 1 and 3, so it's 3 times 1 or 1. I'm just bringing down the sign, bring down the equals. Here the 3's are going to cancel, and I'm left with negative 1 times x, which is negative x. And here the 3's cancel, and so I'm left with plus 1. I'm just bringing down the sign. So now I have a little equation without any fractions, and it's much easier to work with. And I'm going to solve this by adding x to both sides. So I'm going to have 10x plus 1 is equal to 1. I'm going to subtract 1 from both sides, so I'm going to have 10x is equal to 0. And if I divide by 10 both sides, I'm going to have that x is equal to 0. So I have the x coordinate of this point right here. To find the y coordinate, I can plug it into either one of the equations. I'm going to plug it into this one because that one's easier to work with. Y is equal to 3 times 0 plus 1, which is 1. So go figure that I have the coordinate point 0, 1, and I have the point P that was given to me, which is 1, 0. And now I can use, now I can use these 2 points to pop it into the distance formula. Okay, I have 1 minus 0 squared plus 0 minus 1 squared. If I clean up inside the parentheses, that's going to give me 1 squared plus negative 1 squared. That's going to give me 1 plus negative 1 squared is 1, and that's going to give me the square root of 2. So the distance between the 2 points is going to be root 2. Okay? So I hope that helps, and your homework for the weekend is 15 through 19 odd. You're just going to find the distance between the point P and the given line. And in all cases, for the given line, it's a line that goes through 2 points. So you're going to have to compute the slope and find the equation of that line before you even find the equation of the perpendicular line. Okay, hope it helps. I'll see you next week. Have a good weekend. Bye.